Alright. Assalamualaikum warahmatullahi and good morning to all of you. Salam Ramadan. Semua puasa tak hari ni? Okey ya?
Puasa.
Okey lagi Sir.
Puasa mana?
Masih.
Okey, ada yang terconfuse lagi berkenaan dengan kelas, grup kelas. Saya minta maaf lah sebab dalam teaching plan tu saya tersilap tulis grup apa saya tulis, saya punya nama grup, saya tulis grup 2 kan saya kan. So saya minta maaf itu dalam teaching plan tu. Saya plan macam tu sebenarnya, saya nak jadikan saya grup 2 dan 2 lagi grup 1, tapi disebabkan problem with timetable, sebab dia orang dah buat semua dah dalam sistem, so dia orang dah generate nama saya under grup 1. So tak apalah, kita just ubah je lah, tak ada isu pun. No? Kalau yang berminat nak masuk kelas Cik Zam juga tak apalah, tak ada masalah pun. Saya okey lah. Siapa nak masuk kelas Cik Zam masuk, just maklum dia lah, sebab takut attendance tu. Sebab list of attendance yang dapat kepada saya dengan Cik Zam based on dalam apa AMIS tu. So itu that's why last week when we check the attendance, dia tak synchronize lah. So this week we try to make some changes lah to make easy for us to check the attendance. Kalau tak nanti you akan masalah kan. So we try the best to solve any silly mistake lah Okay. So kalau lah yang berminat nak masuk kelas Cik Zam, just whoever want to join kelas Mr. Nizam, you can request from him lah. At least he knows who join his class. Because just last week he told me that his class around 90 something. Actually his group normally 60 something, he told me. So maybe some clash or something kan. So but that's not a major problem, just for information lah. I just want to make sure that your attendance is accountable lah. Okay. So I already post so make sure you join the right group So my class is group 1 and Mr. Nizam is group 2. Okay. Sebab takut I'm worried that the tomorrow class that we have separate time for G1 and G2 tu. For today is no issue. You can choose any class kan. You can choose anyone. No problem. Okay, because we are online right now lah. But for class tomorrow on 1 hour, right? So 1 hour we separate time, different time. For class G1 is afternoon, right? And then G2, my Mr. Nizam, G2 is morning, right? So last week we have class, right? So I'm doing it morning last week kan. So that's the problem lah. I don't want that most of you confused on that anymore. Okay.
Doktor.
Ya.
Maksudnya yang G2 tak payah masuk kelas ni lah kan?
G2 G2 boleh pilih lah sama ada you nak maintain dalam ni ataupun masuk kelas Cik Zam. Patutnya kamu kelas Cik Zam kan? Nur Saibah kan?
Kelas Cik Zam maksudnya waktu yang sama ni sekarang?
Sekarang ni. Sekarang ni kelas Cik Zam.
Okay.
Tapi link
saya
yang
sudah masuk.
Link yang lain.
Okay, thank you doktor.
Alright.
Itu dulu.
Okay. So I hope all of you take a correct group. So Mr. Hasnizam just share the link group, okay, for G2 kan. Alright, wait, I check first. Okay, I saw that a lot of still confusing lagi kan. Banyak confused lagi. So I just give some minutes to make sure you join the correct group. Okay. Okay, please attend your correct class first. And make sure also you join WhatsApp group Mr. Nizam lah. If you are group 2, please join Mr. Nizam class and also the WhatsApp group for easy information sending lah. Okay. But whatever the same thing, ya, tak kisah pun sebenarnya. The class should be shared same thing, same information. Cuma cara penyampaian dia berubah, berbeza. And for the foreigner, you must okay, shall we start our class? Everything is ready, no confusing anymore. Okay, yeah? Can we start now? Alright. Semua diam ni. Semua diam kena panggil nama. So, attendant, I already share the link. Okay. I share again the attendant links. Make sure your name tu salah tak apa. You type short form tak apa. But make sure your matric ID correct ya. Kalau tak, sebab my coding tu it based on the ID number. Okay. Can you see my slide? Can you see my slide?
Yes, Doktor.
Yes.
Okay, thank you. Right, Assalamualaikum warahmatullahi wabarakatuh. So today we will start our class with chapter 2, which is a topic final circuit and load estimation. And last week we already completed the chapter 1 with the title of Introduction to the Electrical Installation Design. So last week we already clear on why we need to design the electrical system, right? So it including safety and the arrangement of the distribution, right? So we have what we call it apa? Ada dua jenis kan. We have two type, right? So Can somebody recap back what we have already covered last week? Ada lagi tak? Apa yang you masih ingat apa yang kita dah cover minggu lepas? Tajuk yang agak banyak lah. There are a lot topic but theoretical lah. Most of them is theory. But you must have a clear understand on the first topic, because that is the idea comes. You need to understand first why you want to do like that, why you want to design become a bus, okay? Why you want to do by the what kan? Kaedah macam mana you want to do the distribution. So why we want to make 30% increment increase our load, right? So for future development and so on. So why we need to put the lot of safety in our design? Why? So all those things we already covered for the last week. So why we just covered it? Because after this you need to design your own building, your own electrical system in the building that we will give next week. Where you need to design everything there, so with the consideration of all of the principle, standard and whatever lah yang that we have already covered last week. Okay, so based on that, your design will be you have very confident with your design lah. So that's why we just make it simple to you for understanding on the first topic. Okay, so today we will continue on the final circuit and load estimation. So what does what do you understand by the final circuit? Siapa yang faham? Ada siapa faham? Okay, and load estimation, kita nak we want to estimate the load. So let's say you have a building, alright, and then first we need to understand based on your design. Okay, you want to design lighting, socket and so on, but what does it mean by final circuit? Which part is we need to call final circuit, and how to estimate the load, right? So because we need to estimate load. If not, we cannot total the total connected load and maximum demand. We cannot do it if we don't have the knowledge on how to determine of that. Okay, so I need some of you still get into any group, so please contact me, DM me lah, DM or PM ke personally, in order to make sure your name is ada dalam any group list lah. If not, confirm you will lose a lot of mark, because our main marks contribution for the subject is coming from project. If you don't join any project, confirm you got 0 lah. So I believe around 60 mark kan, around 60 mark is coming from project aja. Because even we have five assignment, but 5 assignment is group assignment tau. So if you don't join any group, so confirm you don't get any marks for 5 assignment. So you will lose at least 50 mark from there. And then presentation also by group. Okay, by group we separate now, presentation in group mark and individual mark. Okay, maybe around another 10 marks, so 60. And then we have peer review marks, so your friend will give mark to you, 10 mark. So that's why I said around 70 marks is coming from project. So please, okay, please make sure check back your name. Okay, I already stopped for editing because we have case where some of your friend already delete some of your name lah. But I don't know why he's doing like that lah. Okay, he delete some friend, then maybe replace his name and so on. So that's why I said so I need to edit by myself lah. Okay, whoever want to change or want to create new group, so just let me know, give your name and detail of your ID. I will key in for it, and then you can review. You just can check in the same link of the Excel group list. Okay, number 2 is a reference. So this subject we will refer to the IE regulation and also panduan teknik TKR and also the books from Mr. Hasnizam lah. So you can find it, and then for IE regulation 18 edition I already upload into Google Classroom, so you can get it lah. Okay, you can get it, you can download it, and the best thing is you can print it. Okay, because easy to find the table and so on after this. And then number 3 is a group lab. So group lab, I also got a lot of requests for changes of the group lab. So until saya pun tak sempat nak rearrange balik. So for lab, I just open to you lah. So based on 6 group, you just join which one you are able to join. Okay, if you have a clash with this another group, so just join which group you are able, because our lab is very simple and we just do to share on how to do the lab. Okay, there's no assessment on lab. Okay, you come to lab to learn on how to do that assignment or project. Okay, if you don't understand, please ask during the lab session. Because if you don't know how to draw the schematic, how to draw the layout, so confirm you will got a lot of losses during for your mark. So we only have 3 session lab. So last week lab 1, this week no lab, next week lab 2. So we will discuss on lighting, and then next after that there's no lab, and then after Raya, we have a face-to-face lab. That one is last lab lah, lab 3. So maybe we are dealing with schematic, so on. So please make sure you try at your home regarding to this project. And if you have any problem, you can ask during lab session. Okay, because lab session, as I mentioned, there's no assessment, there are no marks. Okay, related to the lab. Okay, if you can check the teaching plan. Okay, you can check the teaching plan. There are no mark related to lab, right? So the lab session we just prepare for transfer the knowledge. Okay, we will teach you on how to do that. We will try to guide on how to draw. Okay, and how to transfer from Excel to the AutoCAD. And then to mesh this skirt into this skirt to make sure your design is correct. Okay, and then related to the number 4 is assignment. So assignment should be released this week, right? Following to the teaching plan. But I'm not release it this week, maybe next week, because the assignment 1 is related to the lighting system. Okay, and you need to draw, you need to calculate of the lighting. So since we are not covered yet the lighting topic, so I hold it first. So I hope I can release it for next week. Okay, so this week relax first, and then next week what we will continue on chapter 3 next week. Lighting topic, and then please join the correct group, and then we have lab 2 next week. Okay, so that's what I remember to update you. Okay, so now we continue our chapter 2, which is definition of pioneer circuit. So first we try to understand, we try to know what does the final circuit, because if you don't understand the final circuit, so you will got confusing for after this. Okay, so bear in mind there are two type. Saya ingatkan sekejap di awal, and at the end after this I will show to you again lah. So the calculation for the final circuit, okay, are different based on IE regulation and also based on JKR, or what we are dealing with our project. So this theory is applicable for your knowledge, okay, but for your project we are not apply it. Okay, sometime okay, the rest at the end of this topic you will see the IEE table lah for calculation of the maximum demand. But for that you need to understand for answering the test at the end of semester. But for your project we are not apply that concept. Okay, so this I'm disclaim earlier. Alright, so because on your project we are following the date of JKR, which is applicable in Malaysia lah. So saya tak mau teach this concept. IE regulation is finished, but that is not applicable in Malaysia. So that's why we try to teach you and let you get some experience related to real one based on your project. So after this, if you got interview or working, okay, so you dah familiar, you're already familiar with the works, that same things. Okay, you can ask your senior on what they have find. Okay, so a lot of your senior are working on consultant, contractor, and they are very happy based on this subject lah, because they can apply 100% on their work. Okay. Okay, so this first thing is okay, definition lah. So the final circuit is a circuit connected directly. Okay, a circuit connected directly to a current using equipment. Okay, so litar, okay, litar yang bersambung kepada ada supply lah. Okay, with equipment, whatever equipment, okay, lighting ke, socket ke, okay, or socket outlet or other point for connection of such equipment. So that's we call a final circuit, meaning that at the last one we have a distribution board, and from distribution board we have a cable, kan, cable, and lastly we have maybe last point lah into wiring, kan. I believe that you already make a wiring during the subject dekat pusat kejuruteraan tu, kan. So you just make some points, you have switch, and then after switch we have load, kan. So that the last load is, we call it final circuit lah. Either fan, ceiling fan ke, exhaust fan ke, lighting ke, ataupun socket. So that's final circuit. So that's we want to learn now. Also aircon also we can declare as final circuit. Okay. And then the second thing is outlet is defined as termination. Okay, outlet, termination of feeds, wiring, feeding. So the outlet is termination, the last one lah. Okay, feeds, wiring, feeding a luminaire. Okay, either luminaire is lighting, socket, or any current consuming appliance. So from this, we've seen that final circuit might consist pair 1.5 mm. Cable, okay, for this one, for 1.5 mm is applicable for lighting and fan only. Okay, very 3-core cable feeding a large motor. Okay, and this would actually coming from the IE regulation, so that's why I'm share yesterday the IE. Okay, and then 3-core cable feeding a large motor direct from circuit breaker or main switchboard. Meaning that this final circuit also lah, final circuit, let's say you have a motor, but motor is 3-phase directly. Okay, direct from circuit breaker. We have a distribution board, and before entering to the load, we need to put the circuit breaker for the protection. Okay, and then the socket outlet, okay, as you can see from the figure, it's a device provided with female contact. So female, that one we call female lah. Okay, female contact, which is intended to be installed with a fixed wiring. Okay, so that one is installed in your wall, right? So that one is fixed wiring. We call it fixed wiring. And then intend to receive a plug. This one we call a plug. So plug is, so you can connect it to any device lah. Maybe TV, printer and so on. So this one we call it a receive plug lah. 3-pin plug. Okay. Illuminated track system is not regarded as a socket outlet. So lampu is not, we call it a socket outlet. So this only we call it by socket outlet. And or kalau kamu connect lampu yang connected to this maybe desk lamp kan. So also you can illuminate track is not regarded as socket. Okay, it's not regarded. Okay, then this is the schematic showing the final circuit. Okay, so after this, I believe also last week you already tried to draw the schematic look like this. I believe lah. This is a sample of the final circuit schematic, which is you need to know that this is the labeling. Okay, if you can see here, okay, from this distribution board, okay, this last distribution board, we have this one. Let's say for here, wait. Here you can see this is the breaker. Okay, I believe you already draw last week. Okay, so here we need to find out the value. What is this? What is the correct value for the MCB? Okay, and it depend on type of load here, type of final circuit here. If you can see here, this label for NOS 2x18 fluorescent fitting. So meaning that this circuit is connected to apa? Lampu lah. So lighting. And also dia ada plus yang kat sini. Plus 2 number of 18 watt fluorescent, and then ada lagi 3 NOS of exhaust fan. So total up you have 6 and 9 point for this one circuit. So this one we call one circuit lah. One circuit lah. So maximum is 10 point for one circuit. That is amalan lah, applicable in Malaysia. Okay, so how to check it? You can check it. You can total up all of this load. You can total it, and then you can check with this breaker. Is it meet or not, or exceed? Okay. If the breaker is not covered by total load, so meaning that you need to reduce load, or you can change the breaker size. But the 6M is a standard for lighting and fan. Okay, here you can see here. Okay, this one, if you want to draw the radial, you just straight line, and then you have a breaker here, MCB. Okay, and then this type we call it radial, radial skirt, and this one we call it by ring. Okay, ring circuit. So after this, if you want to draw, let's say you have a breaker here. Okay, then there's this concept is a ring radial, but for ring you need to have another cable from here and then back to. So we know when you draw this, we know that this is circuit for ring circuit. So normally ring circuit is for socket lah. And this is the way how to label the switch socket outlet. Okay, 13M switch socket outlet. Okay, alright. This is at least you have some idea. Okay, when we're dealing with final circuit, so you have the idea that you need to draw all of these things in your project lah, final circuit. Okay. So before we come to here, we need to understand first all these things, kan? Emergency light, keluar sign, and so on, and spare. And at the end of this topic also, we will cover on how to determine the size of cable. And then on chapter 5, I think we will cover on topic protection, how to select the size of the breaker. Okay, but for this topic, we just study on the first part, the last one. Okay, we need to know what type of the lighting, okay, how does breaker, what type, what the size cable, or how to select the radial and ring and so on after this, for this topic. Okay, if you have some question, you can direct open your mic. You can ask me, we discuss together, because I cannot see your name here and your figure here, because when I share the presentation, so I just can see the whole picture of my slide only. Okay, so the definition of final circuit, you also can open the IE regulation, page 30. You can see clearly related to the what we have discussed before. Okay, so this is some that we have figured out what we call it by final circuit. So it can be divided into following type, okay, which need to different treatment when planning the size of conductor and rating of the overcurrent device. So you need to know lah. Okay, first is socket 13M, which is this one lah. Okay, and this one is related to the BS 1363. If you refer to the IE regulation. Okay, this is the general final circuit lah. Okay, very basic socket. And then number 2, final circuit feeding socket to the another BS EN60309-2. It also socket, but it is the industrial type socket, which is reflect to this type commando socket. Okay, socket juga, but it's different thing. And when we're dealing with this model or type commando socket, so normally it's bigger than normal, which is up to 16M, 32M, and up to 125M lah. For this normal socket, only 13M normal. Why they choose 13? I don't know. Okay, because we just refer to the standard worldwide. Okay, worldwide will use 13M socket. And why? You ask me why 13M? Why don't set to 10M? So it's hard to answer the question lah. Okay, but it depends on the load lah, because we try to standardize the whole world. Okay, the socket is maximum to 13M. 13M, if you check back with your calculator, so how many maximum load that can connected to this socket? Siapa boleh calculate? Try, ni ada 80 orang ni, try. So for 13M, so apakah maximum? What is the maximum watt? Maximum watt can connect to this socket. Okay, try calculate. Sebelum saya panggil nama. Try calculate. What is the maximum for single phase lah? Kan? All the socket is connected to the single phase. This socket cannot connect to the three phase. Okay, so three phase you can use 230 volt. Okay, so just multiply P equal to I kali V kan. I multiply V, so we got, so apa? Somebody help me to calculate.
3 kilowatt.
3. Ngam-ngam 3 betul ya? Tak sampai kan? 2.99 dapat kan?
Ya.
Right, 3 kilowatt So we'll assume 3 kilowatt is maximum for one socket. So make sure after this, if you want to connect your socket, So you just try assume lah. Is it enough or not? And the normal problem is your kitchen lah, kan? You can check your mother's, kan? They connected at our kitchen. Normally they connect the refrigerator, cookers. So all this thing is very high load, kan? So make sure all this load are connected to one socket is below than 1 kilowatt. If not, the MCB will be tripped lah. Okay, at the DB. Okay, this on how to check lah. Okay, number 3 is finding circuit feeding fluorescent. So this one is lighting for lighting. Okay, so very simple. And then number 4, finding circuit for motors. So not just this type motor lah. Whatever motor. Aircon also will declare as a motor because it's movement, kan? Movement. Okay. And then whatever motors, whatever is movement things using a motor, so we call it final circuit feeding a motor. Okay, aircon, and then chiller, and then apa lagi, kan? So all these things is depend on type of load lah. If we are dealing with motors, so we need to know a lot on how does the characteristic and so on. And after that, we will try to discuss a little bit on the motor. And lastly, feeding cookers. Cookers here, okay. Cookers here is related to the fixed cooker. Macam periuk nasi is your cookers that you buy and then have cable, right? So that one we cannot, we don't set it as a cookers, okay. So cookers under this standard referring to the fixed item, which is plugged in or wired directly, no movement equipment, such as your cooker hood, your house, kan? Maybe most of you are still at house. So cooker hood, the kitchen cabinet, kan? And with yang cooker tu, that's one look like this. So all these things, dishwasher, all these things are reflect to the final circuit of cookers. So when we're dealing all this thing, all this final circuit, every part have a different type on how to design it. So you need to know. So when we're dealing with 13M, so what the standard, what the spec we need to follow. When we're dealing with the fluorescent, so how to calculate it. So what size cable, what does a breaker you need to use. So you need to have an idea or standard that we must follow the requirement that already stated in your book lah, IE regulation. Okay, and this is sample of socket lah. I believe most of you already know lah, kan? And this one is the metal clad, and this is not socket this is for ICT. Okay, normally we're dealing with this one. Okay, for your project also you will use all of this thing. So if you draw this one we call one nose 13M, right? So for this one, how to draw, how to label it. So we call one nose 2 by 13M. Okay, because it could combine two socket, but we label it one nose, right? So if this one, so we need to label two nose 13M. So different. So make sure you understand on how to label. Okay, because last time a lot of mistake. Okay, so we go one by one. So we start with 13M socket which is we're referring to BS1363. So main advantage of 13M socket with fuse are you can see from here. Okay, 2.99 or 3 kilowatt. Okay, and if you open this socket, you can see that there are fuse here. So that fuse are 13 amp. You can open it. So after this you can open, but not for stand. You open your own extension plug. You open, is it have or not? Sometimes they put lowest value than 13 amp. Okay. And sometimes they put a high than 13. And the best thing, sometimes person they put a wire to replace the fuse. So make sure on the safety. And then maybe connect with perfect safety to any 13 amp and under certain condition and unlimited number of socket maybe. Ni said unlimited pula. So how? So there's some confusions here. Okay, just now we know that it's limited to around 3 kilowatt only, but on the standard it said that under certain condition an unlimited number of socket may be connected to one circuit. So that issue that we need to understand clearly on this part during our design lah. After this, because after this when you draw this socket kan, so confirm you need to draw the circuit for socket and then the numbers of socket. So how many socket that you want to put for one circuit. So is it, if you refer to this standard, it said unlimited. So unlimited, you can choose you can put 10,000 socket for one circuit. Is it correct or not? Is it possible or not? Okay, so we can check after this. Okay, and then it said for one circuit, and then 13 amp can be fed by either radial or ring circuit. Okay, no problem. If you want to design your circuit using radial circuit or ring circuit, no problem. That's no issue. It depends on your design. Let's say you want to design a computer room, so normally we will use the ring circuit. Okay, but if you still want to use radial, also can, no problem. There's no issue. It depends on you. As long as you have the justification, so why are you doing that? And then number two, you meet the standard of the wiring connection. Okay, let's say you want to do the radial. Okay, so radial maximum 4. That's only 4. So but ring you can put a lot of socket, right? So okay, and this is the radial type of circuit arrangement. Okay, 13 amp 13 amp. So if you're dealing with radial, okay, let's say you have no return back cables, only one side, one line. So let's say for the we see the live. So live from here it goes to one socket number 1 and then parallel to socket 2 and then parallel to socket 3. Okay, and then last here. Okay, so that now we go to the final circuit for ring circuit. Okay, if you have some error typing, please correct. I believe that previous note the state here is radial kan. So a ring circuit is utilize one additional conductor to loop back to sending end. Okay, the socket in the ring circuit are fed by 2 parallel connector. Okay, let's say this is our supply. So we just see on the live, okay, live dia pergi sini, come to circuit, go from here to here, and then last circuit, and then it will come back to the earlier point. Wait, I have call. Okay, I hope you understand. For this circuit arrangement, very simple. At least you have the idea. So why you want to use a ring? Why you want to use a radial? It depends on the location. Okay, so normally we use the ring circuit in order to make backup. Okay, let's say you have a computer room or any room lah, which is you want to make sure safety, to make sure they are always have supply. Okay, let's say this plug is broken. If you are normal condition, okay, so the supply is coming from here to here and here. So since the socket is broken, so there's no supply to this one kan, and so on. If you are radial circuit, but since you are connected using ring, so the supply is coming from here. So meaning that this circuit and this circuit and also here still can operate. So this is the advantages of the ring circuit. Okay, understand or not? Faham tak? Kalau compare this one, okay, let's say let's say here this socket is broken or fault or short, anything. So only this one you can use kan, only this circuit you can use, and this one and also this one you cannot use anymore, because since there are problem here, so the rest connection will be cannot be used. Okay, alright, I hope you understand on the circuit arrangement of radial and also ring. Kalau tak faham, you boleh tanya lah. Kalau you segan English, you boleh tanya bahasa Melayu juga, tak ada masalah. So I need to appreciate our friend. Okay, we have 2 or 3 member from Saudi kan. Okay, Muhammad and so on. If I am talking on Malay, so most of them they cannot understand lah. So that's why if you have any question, you can ask me lah. Okay, Muhammad, Mamdu, are you here today? Saya nak kena tengok nama orang syok panggil apa kan. Ada tak syok, menjak panggil seorang-seorang ni. Saya join. Okay. Right. I just want to see a name, easy for me to call somebody ya. Okay. Okay, Muhammad Adin. Are you there?
Yes, sir.
Okay. So are you understand for the ring and radial circuit arrangement?
Yes, sir.
Okay, good. Okay. Alright, so we continue. I try to finish earlier since we are fasting kan. So semua dah letih berpuasa ni. So I try to finish early, but we need to complete this topic for this week. So if we cannot finish today, so we will continue tomorrow lah. Okay. And then, okay, recommendation exists in the IR regulation for standard circuit arrangement with 13 amp socket. The permit 13 amp socket to be wired on the final circuit as follow. Okay, so how to do the connection of 13 amp? So just now we can see that it said that unlimited number, right? So it have certain condition only if you want to make the unlimited. So we refer. Okay, we can see this concept first. Okay, so number one, and unlimited. Okay, unlimited. So now we try to discuss on how many switch socket outlet. Okay, this one. Let's say you want to design the socket in one room. Okay, so how many maximum number that you can put? Okay, because normally somebody said only 1, somebody said only 2, and then 4, 6, 10. So now you're confusing. So which number? What number? Kan? So Nabil tahu tak berapa? Normally berapa bilangan soket, normally how many number socket we can connect into one circuit? Nabil, Arif.
Ya saya doktor.
Berapa? Dia buat wiring banyak ni. Nabil ni MPP kita ni. Kan?
Saya? Tak ada bukan.
Orang lain lah. Nabil lain lah.
Bukan. Bukan saya.
Okey, berapa? Tahu tak berapa bilangan soket?
Saya tak tahu lah doktor.
Tak tahu lagi ya? Alright. So I hope after this you know lah. Okay. So number one, it said that room not exceed. Okay. Katakan satu bilik tu, this one, this area. Okay, length and width you multiply lah. You got 100 meter square. So this room are applicable to use unlimited number of socket. So you can put 100 ke berapa kan. Tak kisah. It depends. But you need to use 2.5 mm in ring circuit. Okay, clear. It said ring ring. Okay, this is a sample of ring Okay. And protect by 32 M of MCB or overcurrent protective device. Okay. You can use unlimited, but you can see this in actual practice. We only our design up to 10 only. Connect to final with 2.5 mm. Okay. Even in the standard set unlimited. Wait I have another call. Wait Hello. Salah Yang kelas. Yang kelas. Pasal. Okay, so sorry for the interruption lagi. Kali kedua. So maybe ada next project kot. Okay. So we're going to number 2. So clear, number 1, it depend on 100 meter square of room. Okay, you can put unlimited, but normally we use 10 saja, maximum 10. 2, 4, 6, 8, 10. So ini tak boleh lah. Okay, 10 only Okay, number 2. So number 2, you said also unlimited number, sama, for room with 75 mm. Okay, but okay, use 4 mm cable. Okay, for radial. If you want to use a radial, okay, you want to use a kering tekak dah lepas Okay, radial circuit, you must use cable size 4 mm for room 75. And MCB 32 M. Okay, number 3, socket for room 50 meter square. You can use 2.5 mm. Okay, this is also unlimited socket. So berapa banyak socket, how many number that you want to connect for this socket for room 50 meter square. Okay, on radial circuit, and the breaker is 20 M. That's rule number 3. Okay, so we have but in Malaysia, okay, this one until number 3 is stated on the IA regulation. But applicable in Malaysia, okay, applicable in Malaysia, we use this table, and I hope all of you try to remember this table because you need to refer to this table during your design after this. Okay, So confirm Mr. Hasniza, Mr. Faizul and me will ask you based on your design that you are showing during the presentation. Let's say you shows one circuit, you put 10 numbers of our socket. So we will ask you, you are referring to what type of socket outlet? And maybe you said dah you pasang 10 kan. So confirm you said, okay, I'm referring to number 3, which is ring. I'm using ring. Okay, ring circuit up to 10 numbers. So okay, 10 numbers is okay. And then 13M, okay. Kan? Make sure you put 13M and not 15. 15M is not applicable for this one. 15M just for aircon sahaja. And then we try to check the size of room. Okay, check. The room is bigger than that. So if the room is bigger than 100 meter, so this one is cannot applicable anymore. Okay, clear on that, And then we check the drawing. You said a ring, but your drawing you just draw radial. So make sure. Make sure you need to complete all this thing. Okay, and then we will check the size of our cable. So you said ring, okay, 10 number socket, ring, and then you must use 32M. Okay, so and then this number, okay, this normal practice in Malaysia. Normal we use one only in radial. Okay, radial 16M MCCB. Let's say this is MCCB. This is a socket, right? So MCB. So if you want to use 16M, so we just connect only one socket. You can use 16M. Okay, and this size is 2.5 mm. Okay. And then if you want to use 2 here, socket, double socket, okay, but you need to change the value for MCB to 20M. Okay, 20M. 2 socket. All these things you must check. Yeah, okay, before you design, you must state it clearly. Okay, radial also. This one radial. We're talking on radial, and also this here. So radial, you can normally radial we use 2. This is the normal connection on the JKR standard, normal. So one circuit we just put 2 number of socket. But maybe you want to save or you want to make it easy for one circuit for one room. Let's say one room you want to use radial, okay. You can still, but maximum until to 6 number only if you want to use a radial. Okay, and then the breaker you must use 32M, and size cable you must upgrade to 4mm if you want to use the radial concept. Okay, maximum 6 only. Okay, and then but if you want to put a lot or more than 6, so we are suggesting you are using a ring type of circuit. So meaning that this circuit you just put another point. Okay, just put it here, and then you can use up to 10 number of socket. And then the cable you can reduce back from 4 to 2.5. So jimat balik you can save a lot of money here, 4mm to 2.5 kan. And the breaker is same here to here, right? So that's you can use this table during your project implementation after this. Okay, so this is a guide, okay, on how to decide the final circuit for socket. Okay, clear? Ada apa-apa nak tanya tak berkenaan dengan ni? Sebab table ni memang you akan pakai. You confirm must remember this table. Kalau tak, your design will be wrong design. Please use this table for project only. For test, not applicable. Maybe applicable also. Maybe. But this is applicable for Malaysia practice. Okay. Confirm understand Clear?
Clear Doktor.
Alright, thank you. Oh, now we have 98. Okay. Memang nama you all ni dalam grup saya ke? Ataupun tak mau join kelas Cik Izam? Kelas saya rasa dalam 70 lebih je. Okay, tak ada masalah. Okay, we continue. Now we're going to number 2, which is socket outlet also, but this is British Standard 60309, which is normally we call it a commando socket lah. This you can see this is commando socket. Pernah jumpa tak this socket ni? Have you seen this socket before this?
Masa?
Yes.
Pernah.
Pernah Tak pernah tu?
Kat lab.
Dalam lab.
Alright, betul, kat lab ada. Kat rumah siapa ada pasang ni?
Kedai makan ada.
Ada? Oi, siapa dia yang cakap ada rumah siapa ni? Mana? Rumah siapa ni tadi? Siapa yang cakap ni? Saya tak nampak nama. Ada? Boleh share sikit? So you use this socket, you said you install this type command socket in your house kan? So you use it for what Boleh share? Oh, hilang lah mengaku dah. Tak apa lah. Ya. So,
Bukan rumah saya, rumah kawan saya, dia berniaga untuk rice cooker yang besar tu dia pasang yang ni dalam kat rumah.
Oh. Dalam rumah Ni
Yeah.
civil organization Okay, thank you.
Yeah.
Okay, that's because that one 3-phase or single phase? Tak tahu you tak sure yang that one
3 phase.
3-phase. Okay, that's why you use like this Dia business ke berniaga
Ya encik,
Kau kedai
berniaga.
Alright. Thank you, Siva. Okay, this is normal lah. Normally rumah kita tak pakai lah yang ni. Except just look like our friend tell lah. Dia just use for industrial because dia buat kedai masak kan. Maybe they open a restaurant. So for cooker. So yes, for safety matter, that's good. You can use this one and easy for plug in for safety and sometimes they put outside. And right now, I'm already installed two numbers. The electric car. So electric car they must have the charger kan nak charge kereta tu. So you need to use this model lah to put into your house lah. So normally 3-phase lah. So kalau rumah single phase tak boleh nak charge kan. So the supply must have 3-phase. Let's say you have a 3-phase supply into your house. So you can make a wiring and put it here into outside of your house lah. And then from then you can make a connection for electric car charger. Kalau lah after this, I believe that most of Malaysian car will be changed to electric car lah. So right now dia masih peluang bisnes tu banyak lagi. You can start learn on how to make it. Very simple. If you can make this one connection easily, you can get 1,000 simply 1,000 tau. You just put one simple circuit ni je. Okay. So that one we call it heavy industrial type and suit for single or 3-phase. Okay, either single phase or 3-phase. And normally the rating is from 16 up to 125 M. Commando socket lah. That commando socket. Okay, let's say you have a big load. Okay, and then you just check the rating of the load lah. Okay, normally it's up 16 to 100 M lah. So you must use this type. You cannot use previous type 13 M kan. If let's say you ada pump, you have pump, normally pump lah, it's high M ni. So you just check nameplate tu how many M produced by that pump. So let's say it said 17 amp. So you cannot use the plug lah. Okay, the socket. Okay, please change, please design. And in our part, in our this our design kan. You are designer, and first thing you need to study on your load. Let's say your customer give you that said, okay, in my house, okay, I have this load, okay, motor, pump, water tank, water harvesting, and so on. And then from that you need to clarify, oh this load is how many amp. So from that you need to differentiate lah. This circuit must use this type. This circuit must use heavy industrial type isolator and so on. Okay, so this is the way on what our designer doing the job lah. So okay, so sebab tu that's why you need to clarify first. You need to understand what does a final circuit type tu. Kan? Normally we only know the lighting and normal socket, right? But for this thing, normal engineer they will follow this regulation lah. So that's why that goods for you for information. After this, I hope you are not doing wrong design. Okay. So and then the 16 amp socket with a single auto phase. Only radial. Okay, 16 amp, so you can use it, it's unlimited. Okay, the number of socket you can connect unlimited, how many number you can. But okay, I said but okay, the breaker MCCB must not exceed 20 amp. Okay, but in Malaysia we are not applicable the number ni, this one unlimited is not applicable in our design. Our design for any isolator, for any commando socket, just are able to connect only one load, only one load. But this regulation is coming from IE, so I need to share the correct thing lah. But applicable, it depend lah. So sometimes maybe after this you have fight dengan customer and other authority ke, so you can open back this standard, you can open lah related to the BS. Yes, you can connect to many number. Okay, as long you use correct breaker size, okay, and then you can fight lah. You can use unlimited. Only in Malaysia we are not apply all this type lah. Okay, only one only one should be connected to only one circuit. Okay, it said. So higher rating will be wired on separate circuit. So normal practice on your design, if you want to use a commando socket 16 amp and above, so you just connect only one load. Okay, let's say you draw macam mana circuit tadi. Let's say you want to use here. Okay, 30 amp also can. So the commando socket you just put it here and then just flip one nose. Apa-apa load lah. Load tadi kan, macam tu. Okay, then this is number of the type of is commando socket. Alright, now final circuit for motors. Okay, for motor we have a lot of things lah. Okay, first thing we final circuit for motor need special consideration. Okay, because it governed by some regulation. Okay, the rating cable in circuit feeding motor is on the full load current of the motor. Okay, effect of the starting current will need to be considered if frequent starting is anticipated. Okay, Okay, you can use this one, page 141. You can open it. It clearly said that, okay, I have a lot of experience during the installation of the motors. Okay, normally motor pump air tu. So even though the nameplate only said maybe 1 horsepower, okay, but for motor, okay, this full load 1 horsepower equal to berapa? Siapa tahu 1 horsepower berapa watt? Berapa ya?
746.
Okay, thank you. 746. 746 watt. Okay, so you need to know, but during your design, you must consider the starting current ni. Because during my experience, previously, I'm not consider the starting current. So the problem is the breaker. Okay, let's say this is the breaker. Then I put the motor lah. Okay, so let's say the motor is 746 watt. Kan? Kalau 746 watt, okay, berapa breaker kat sini kita pasang? Let's say 1 phase. Siapa boleh? Can anybody calculate? How? Can we use 6M? Cannot lah. Cannot. Because 6M only for lighting. Right. So we already learned just now kan. So can we use 16M? Is it enough? Boleh kan? Puan je tak tahu, kira lah sikit. And very simple, how to decide this value? You just calculate I P over V kan. This very simple formula. So P 746 divide by supply lah. And so bahagi 230. So you dapat lah berapa? You dapat apa?
3.24.
3.24 M. Betul? Kalau betul? 746 bahagi 230. 3.4 lah. Lepas lah no. So you got 3.2 M. So is it enough we apply 16? Can or not? Can lah kan, sebab our load only 3.2 kan. So we put 16. So it can be choose here. Okay, this normal. Okay, let's say this load you multiply by 3 because normal starting current are triple now. Triple. Okay. Okay. If for this motor, is it 16M can be used? Can or not?
Can, sir.
Still can, right? Because
Yeah,
yes, still can. Okay. So in this case, let's say your motor just 1 horsepower, so system still can use. This is how you design. This how you decide the breaker size. Okay. I hope you understand the flow. If you understand the flow, should be no problem during design. This design very simple je. Senang saja this topic. Okay, in IE regulation state all equipment including cable, every circuit carrying the starting, accelerate and load current for motor should be suitable for current at least equal to the full load. No, at least full load current kan. Okay. So just now before this I just follow this one lah. Follow equal to full load current. When rated is according with system where the motor is intended to be intermittent duty, frequent starting and stopping should be taken any cumulative effect starting or breaking current. So it depend on the type of load of the motor. Let's say you want to design, you need to know, is it motor always starting and stop? Kan? dia selalu nak kena on off macam aircon kita selalu kan, every time kan, every day we want to start and stop. So that one you need to consider the starting current lah. Alright. So yang ni dah clear. So for motor again, every electric motor exceed 0.37. Ini equal to apa? Half 1 horsepower is 746. So this one is half half of horsepower. Setengah horsepower. Shall we provide by control control equipment. So any motor, tak kisahlah, whatever equipment with rotating, we call it motor with 0.37 kilowatt. So shall be provided by control equipment. So control equipment ni apa? On off tu dia, on off button tu. Okay, switch lah. Control equipment. Okay, normally we call it DOL DOL. DOL. Okay, ataupun isolator. Okay. Which is incorporate protection against overload of the motor. So we want to protect the motor first. Okay, we try to provide the protection to the motor. Okay, and then several motor not exceeding each can be supplied by one circuit, provide protection provide. Okay, so kalau below than half horsepower ni, it can be directly one circuit, and then you just put breaker itu normal. Because in our design kan, okay, from DB we have a breaker, and after breaker we have a load So this breaker must have, okay, must have. But if you're bigger, let's say the bigger than half horsepower, so you must provide the control lah. Yang dia control pula itu. So we call it control lah. Okay, control. Kita nak control. Okay, right. This is sample of the control circuit tu lah. Okay. All isolator, we call it isolator. Must be suitable place, which mean must be near the starter. Okay, katakan you punya aircon kat sini. So you connect yang dekat je lah dengan dia. Jangan letak jauh-jauh kan. Please don't put it very far from your load. Okay. But if the motor is remote and out of sight of the starter, then an additional isolator must be provided near the motor. Okay. So kalau jauh juga, let's say your DB very far, so you need to provide another isolator very near to this. Okay, you put. Normally kan, you jumpa kan isolator kan, dia ada dua ni, red and green. Or this model lah, on and off. Okay. So the function just for safety lah, safety. Okay. The cutting off voltage does not include the neutral in system where the neutral is connected to the earth. For the purpose of mechanical maintenance, okay, accelerator enable the person carry out maintenance to ensure that all voltage is cut out from the machine. Okay, and control being worked open and to be possible for someone else to switch again. So that's why isolator must put near to this motor lah. Kan, we don't want that let's say this is supply or DB here kan, and then because of motor normally comes with very high ampere and it's related to the life kan, or life. So let's say we already off the supply, and then we doing the maintenance here. Because they are separate room, let's say this is separate room. Okay, the another guys come and then you are doing a repairing here. Okay, you try to repair the aircon, and then just now you just off kan. But let's say some guy kan, dia duduk, he stay in another room, and then why they are blackout here, and then come check, oh this DB is off So you just now you touch the live current, live cable, and then this guy open back the supply. So you'll be shocked here lah, kan? Keras lah you kat atas tu. That happen. So that's why we apply as so don't see if he cannot see you here, so you still can be safe because you have again. Also same for your design. After this, let's say you have a design related to the motor, please make sure try to allocate okay, the isolator near to the final load. Kan? I'm sorry that I'm still not sharing ataupun assign project drawing to all of the group until today lah. We are still decide yet, okay, the project for your group, because we are trying to make a different from the previous project. So we are looking at to a new building and related suitable to your level of your design. So I hope that we can finish it by this week lah. So please pray for us to complete and to give your good drawing, good project lah. Sebab we need to find a real drawing from the outside lah. Okay. Kita bukan bagi drawing yang biasa-biasa kat you all. So we give a real drawing tau. A real drawing, project AutoCAD, a real building. A real building that you can work out in real things. If you entering the industry after this, so the same thing you will facing. Okay, so please take it as a advantage. Okay, and then final circuit for motor starter. For another thing is motor starter. Okay, it necessary that each motor provided a starting and stopping, and so placed as to be easily worked by a person in charge of the motor. Okay, easy kan, senang, easy for you to control the motor lah. So macam aircon, look like aircon, right? So we have a remote and then we have separate switch to on and off, kan, to start and stopping. Normally necessary. The starter controlling every motor must incorporate mean ensuring that the event of drop voltage, failure of supply, motor does not automatically start or restoration supply where unexpected restarting could cause danger. Okay, so normally starter should be fit with under voltage strip, which have to be manually reset after having trip. This issue if there are some fault for the motor. So if you have the starting, so you can directly control by at the motor directly. Compare if you don't have the start and stop control there, so you need to find where there's a breaker, for the aircon so that the issue lah. So that's why normally we design the motor related to the motor. We have provide the start stop switch near to the load. Most of our design, first we try to see the safety issue. Okay, so you try to set, just I mentioned last week, try to set in your mind during the design. Okay, during the design you just, I want to design, why I put it, why I'm doing like this. So you set your mind all of this thing for safety. Is it possible I put it here? Why? You ask yourself why? Because after this, when you join the industry, kan, so they are forgetting the safety. Okay, just I just told the real life. Normally, not all. Normally normally they are looking for saving. Semua nak jimat. They want to save here, but they have forgot on their safety. So you as a new designer, after this, try to start with you lah. With you all whatever design, you try to put it, the safety is number one. Okay, right now what number one? Number one is money. Okay, right now lah, I told you, right now everything is number one is money. So they don't care anymore about the safety. So that's why they install cable kan. Based on safety, we must use and we also study kan. Here 4mm right just now, right? 4mm cable. If you check back here, this okay, this table. This is whatever what I have found in real life. Okay, if they said they want to install maximum number, okay, because if they install a lot number socket, they can save cable kan. First they don't want to use ring, because if you want to use a ring type, you need to extra cable from the end to come back to the DB. So a lot of cable. So they don't use a ring. And then number two, ini dah salah satu. Number two, they want to use a radial kan, but they use 10 number. The size cable normally should be 4mm, but they won't use 4mm because 4mm and 2.5mm a lot of money also. So they won't use it 4mm and they use 2.5mm. They nak jimat. Okay. So that's the issue right now. So you are new designer, after this please replace it lah. Okay. Please you dah ada knowledge, you apply it. Okay. Okay, and then this is the simple lah, start and stop no. Okay, every motor have their rating exceed, okay, half horsepower, must be controlled by starter, okay, incorporate overcurrent device. Okay, normally dalam ni, normally inside it also have another breaker, and the connection to the DB also have the another breaker. Okay. The starter are generally fit with thermal overload. Okay, normally using thermal lah. MCB, our MCB. Sorry I forgot to copy the figure of MCB. Normally the operational of the main circuit breaker is based on thermal. So how thermal? Let's say you have this aircon, okay, aircon or motor lah, whatever lah. Okay, let's say your motor have overload. It's overload. When you have overload, so this cable will be heated, okay, and the temperature will be rise lah. And this breaker only trigger the temperature rise. Okay, it depend on type of breaker. So once they are exceeding the value of the temperature, so this breaker will be cut out lah, trip. So this is how lah. Okay, this time lag can usually be adjusted and normally set to operate 10% or above full load. Okay, normally they will set, okay, 10%. And just now electronic protective relay are available. And normally most of the breaker they are using electronic protective relay lah. Okay, rating protective device. So following to the IE regulation 433-2-2, I suggest that you try to understand on how to use your IE regulation that I share. Okay, let's say 433-2-2. So how to find it? You try to understand your book lah. I already give a book with price of 60-100 tau, buku tu saya bagi tu. 60-100 macam pelik. 600. 600. Okay. State that overcurrent protective device may be placed along the run of conductor. Okay. Providing no branch circuit. So only one. So let's say this protective device along ni lah. Maksud sepanjang ni dia kena ada protective device overcurrent. Okay, so only dia kata no branch, maksudnya meaning only one. Okay, no branch meaning only one motor. Therefore, overcurrent device could be one incorporated in the starter. Okay, so in the starter. So this breaker in the starter. And need not to be duplicate at the commencement of the circuit. So cannot copy lah. So dia tak ada macam ni kan. So dia nozzle motor. So this one is cannot lah. Alright. So one protective device only covered one motor. Okay, and then short circuit protection device also must be provided to protect circuit and should be placed where the reduction occur. Okay, in the value of current carrying capacity of the conductor installation. So the device may, however, place on the load side, okay, of a circuit providing the conductor between the point. So I need to read all this because this word is coming from the IE regulation. Okay, sorry ya. The conductor between the point where the value of current carrying capacitor is reduced and the position of rotor do not exceed 3 m. Okay, 3 meter length. And providing the risk of fault current, fire and danger 2% is reduced to a minimum. Okay, based on same regulation 433-2-2 related to the motor, it also asks for designer to provide also short circuit protection. Okay, and the circuit must be not exceed 3 meter. So when you design after this, let's say you want to put one motor for your design, for your circuit, so make sure, so let's say you have one room, okay, let's say you want to decide motor is placed here and your DB here kan, your DB let's say here. So you must decide the cable run pathway kan, laluan kabel tu is not more than 3 meter. Okay, you must okay, you must decide because the location of DB is depend on you. Okay, so that's why lah they put the regulation and we need to follow them. If they are very far from the DB, so you need to provide separate DB. Separate DB. So from here you just put a new DB just okay to control this motor. Okay, when motor take very heavy and prolonged starting current, it may well that be fused will not be sufficient to handle starting current, and it may be necessary to install overcurrent device, okay, and install larger cable. Depend lah. This is what we call common sense lah kan. Let's say your motor is very heavy duty motor and prolongs starting current on off. So you need to provide okay very high model of overcurrent device, okay, or you install larger cable because okay, let's say your motor connect to the cable, right, this cable, and this is your breaker. Okay, so either you control this breaker or you control this cable. But normally, okay, in design, in the standard, it said that IB, this is the IB lah, design current, must be, dia kata ni lah, IN must be IZ. Okay, so IZ is coming from here, cable. Okay, so cable we want to protect, okay, and this one is IN, this one is IZ, and this one is IB lah. Normally IB we call it IB. IB is design current to a specific value of current. Okay, we want to protect this motor. Okay, so which one you need to consider first. Okay, so the value is it from here. If you understand for this formula, so easy for you to decide the design lah. No need to remember all of formula and so on. Just remember this very basic. So this one, so size cable, we call it current capacity lah. Must be bigger than protection. Let's say the protection is bigger than this one. So what will happen? Ada siapa ada idea? Apa akan berlaku kalau nilai IN is bigger than value of IZ? Siapa? What will happen? Any idea? Somebody can share your opinion? Ada 100%. Macam mana ni? Kelas Cik Zam dah habis ke? Semua masuk sini? Amar Zuhairi. Ada tak Amar Zuhairi? So what will happen if this breaker breaker size is more than capacity of cable? Amar, ada? Kau masuk join saja ni. Tak masuk kelas pun. Ada. Apa akan berlaku Amar? What will happen? Kalau ni breaker kita ni lebih besar daripada kabel size. So apa akan berlaku? Ada idea tak? Kejap ni kan tak tahu. Hilang dah. Okay, tak apalah. Masa boleh limited ni. Okay. So if like that, okay, if you set the breaker of the circuit is okay bigger than cable, so confirm this let's say this fault happen here. Okay. The fault come to cable kan. And this is your DB lah. Kan. DB, okay. So this breaker normally will be trip lah. Kan. Kalau dia nilai dia kecil ni. So this breaker will trip. But you have wrong design. So you put the IN is bigger. So what will happen? This cable will melt. Apa? Lebur. Melt lah, melting. Because this breaker still okay, but the insulation of the cable cannot carry anymore the size the thermal of the fault. So the cable will be broken lah. So in your design, you want to, yang mana lebih mudah? We want to replace breaker or replace cable? Which one is easy?
Breaker.
Kan, breaker kan. So you must design that. That's why we put a protection here kan. Breaker, the function breaker. Kalau you design, you want to make cable akan rosak, you kena fikirlah macam mana cable nak tukar cable. And the another thing is, once the cable is fired, so normally the overall of the premise will be burn also lah. So terbakar lah bangunan tu. So that the issue. So normally when the house is fired, so dia akan cari UR lah. Okay. So with the 3-phase motor, if you are not large enough, carry the starting current, it is possible that one may operate. Okay, this causing the motor run on 2-phase. So that the issue lah. Sometime for motor, kan. So kalau if you don't protect clearly, so it will affect it to the motor. So normally motor we have 3-phase, right? R, Y, B motor. So it will running clearly. But let's say you are not protect clearly, and then from that fault come here, and let's say phase B is broke. So the motor will be work only two phase. Two phase. So what will happen to the motor? So confirm this motor will be damaged after for some time. So you must protect clearly. Okay. Okay. Backup. Okay. The ideal arrangement is to backup the overcurrent device in the motor starter with HBC fuse link. Okay. This is simple lah. HBC fuse link, because normally for motor it require very high temperature, kan, very high current, and this fuse design with a very high starting current it possible. Okay, possible to cover the overload device. Alright, banyak pula call masuk ni, sorry ya. Okay, right. So then so settle for motor. Now we coming for cookers pula. Last part is for cookers. Under IAEA regulation for 76034, a cookers is regarded as specific equipment. I just told earlier kan. So fixed equipment yang melekat di dinding siap-siap tu. We cannot movable. So that one we state it under cookers lah. Kan, macam blender. Is it we call it for cookers? Tak lah, sebab blender we have separate cable kan. We plug anywhere. So that one we cannot call it as a cooker. Okay, such equipment must be under control for a local switch, usually in the form of cooker control unit. This switch may control two cookers, provide both within 2 meter. Yeah. So what I want to share here related to this topic, di mana muka surat table IEE. Okay, so I will have this book, so you can open page 21 lah. So page 21 we can see clearly IAEA on-site guide diversity factor, and I believe also on the books of IAEA regulation you can try to find it lah. Tapi saya rasa tak ada dalam tu. So what I'm trying to say that you need to familiar with this table, which is when we're dealing with the cookers, so we need to refer to the item number 3, which is a cooking appliance here. So how to calculate, let's say for the household, in this table it said 10 ampere plus 30% of a connected cooking appliance in excess of 10 ampere plus 5 amp if socket outlet incorporate in a unit. So for this topic, you need to familiar with this table lah, IAEA on-site guide diversity factor tu. Okay, so you need to start familiarize ya. Okay, and tomorrow we will try to make some exercise related of this calculation. Okay, so today try to find this table and try to understand on how to use it. Tomorrow we try to do some exercise lah, kan? Alright, so what we call it, in many cases this control unit incorporate socket alert, although often such socket is not safest position for use supply. Okay, and it is often considered safer to control. Normally we have a control system for this separate socket. And the protective device is often the most highly rated in installation. So that's why for kitchen, normally we have separate breaker for all socket. Please don't use the ring circuit for kitchen lah. Okay, I suggest you just use the radial but with high high capacity of breaker and also high capacity of cable, because we know that all load at the kitchen with related to the cookers, and the standard already told us related to this cookers ni kan. So we need to design properly when we dealing with the cookers ni. Okay. So see table 2, that table lah. Okay. So sorry because I'm not share the table yet. So you need you try to find first lah. After this I try to crop lah. Or I believe that some of your friend already have this book, so you can open page 21. You can see that. So Azus is look like lamp lah. So electric discharge lamp may be divided into two group. Okay, lampu pun ada dua jenis. We have two type, which is low voltage and high voltage lah. Okay, operate in 200 volt. Okay, up to 250 volt. And then the thing is high voltage. High voltage ni normally neon lah. Neon ataupun lampu sinus tu. So lampu sinus tu it require ni lah, this one. Require high voltage. Okay. First group including the fluorescent lampu biasa-biasa. So this one under first group. Okay. Fluorescent, LED kan. Rating dia 8 to 125 watt. Sodium lamp, okay, and also pressure mercury. Why you need to know? Because under calculation of lamp, you need to know the separation of this two type. Kalau you guna low voltage, it have a different method of calculation. If we have a high voltage, you need to follow the another calculation. So tomorrow we will try to calculate it. So low voltage discharge, okay, regulation govern, okay, said that additional factor to be taken into account. The current rating is based on the total steady current, okay, which include the lamp and associated control gear. Yang ni control gear ni cuk tu lah, okay, cuk balas lah. But right now we are dealing with LED kan. Most of our lighting use LED, so when you dealing with LED, there's no choke anymore. This one is for fluorescent, normal lighting, kan? Kalau you buka, you ada buka yang satu choke lah kita panggil apa? Balas. So that one, when you dealing with the type of lighting, so you need to multiply by 1.8. And it based on assumption that power factor is not less 0.85 lah. Okay. So when you want to calculate the lighting, so you need to multiply by 1.8. But this only applicable when you want to calculate following to the IEE concept. Okay. For JKR type, so we will discuss on lab lah, on how to calculate. Very simple. Okay. Okay, and this is how to calculate lah. Okay, total load P rated multiply by 1.8. Okay, let's say 36 watt kan. So you just multiply by 1.8. Okay. And then for some cases, okay, 1 to 5 watt lah, the highest watt of lighting, so need to multiply by 2 factor je. Okay, that value is depend on the value of transformer. Bukan transformer besar tu, transformer include in the lamp. Okay, or we call it by choke or balas lah. So that value is coming from there. Okay, ataupun dalam kalau JKR style, let's say we have 36 watt, we just add 6. Okay, 6 watt is for balas lah. Okay, that is the concept of JKR, so that's why it comes 42 watt lighting. TCR. Okay, and then another thing is circuit switch. This switch lah, switch on off switch kan. So you need to you should be rated at twice of the design current. Let's say apa, you want refer when you want to buy or you want to design it, you just put it value of twice of the design current. Let's say design current is 10 amp, so this switch must be capable to cover up to 20 because twice, right? Double it. And also quick make and slow break switch must be used. Okay, quick break ni is not be used because might break the circuit that peak of frequency wave. So you just when you deal with quick make and slow break, normally they understand lah. Okay, quick make we just open it directly, but for break slowly switches. Okay, quick break must not be used. Quick break we must slow. Okay, as they might break the circuit at the peak of frequency, so that's why they are don't allow at quick break type of switch. Okay, because this issue the peak of frequency wave. Okay, now we deal with MD, maximum demand and diversity factor. Just now we already know on final circuit, and to calculate the final circuit we just total up the value. Let's say the lighting is 36 watt, so let's say we have 2, so the TCL equal to apa, 72 betul 72 watt kan. Okay, so that is TCL, total connected load. So now we need to know on the maximum demand. Maximum demand ni apa? So maximum demand you can see they define also on BS7671. To be clear, such as term understood by all concerned the design process. Maybe normally maximum demand may mean different thing to the supply engineer and installation design engineer. Okay, maximum demand, what I can say that we need to know maximum demand. Why? Because in Malaysia, the TMB or utility, they allowed only allowed maximum demand value compare to the TCL. Okay, TMB just follow the MD value. Okay, not the TCL. So that's why we need to calculate the correct value, the actual value. Okay, so maximum demand is actual value that you are using. Okay, normally, okay, let's say for here 36 watt lamp, right? So what does actual value? So we need to calculate it. How to calculate? We need to multiply by diversity factor. So diversity factor ni apa pula? So what does it mean by diversity factor? So sorry okay, connected load is sum all load lah. Okay, very simple lah. As I just told, this 36 by 2. This is we call it connected load, total connected load. Diversity factor is a ratio of sum maximum power demand of subdivision. Okay, and the value we can see from this on site guide diversity factor, or this page 21, or I will upload later this table. Okay, but you need to know how to use it. Diversity factor is numbers, faktor kepelbagaian. Maksudnya how many time you use that equipment. So normally we do not know. So that's why the IE just provide the table that we can simply use it for our guide. Sebab kita pun tak tahu berapa kali kita nak guna soket tu, and how many time you want to use the socket in a day. So normally we do not know kan. So that's why we need to refer to the table to make sure we get the correct value of maximum demand. Okay, so maximum demand, okay, is the highest rate at which power is consumed. Okay, ini yang TMB nak. Alternatively, express the highest average rate in electrical consumed. So you can use this formula, connected load multiplied by diversity factor. So diversity factor, you refer the table, you multiply by the TCL, so you got value of MD. So that's all for today. So tomorrow we will try to make some example here. We try to calculate in order to understand more on the application of the what we have learned today. So any question? Patutnya saya tak ada tanya soalan ni kan. So okay. So if there anything you want to ask, you can ask tomorrow lah. Okay. So that's all for today. So I stop here. And then please please fill out the attendance form and see you tomorrow lah. So tomorrow my class in 2 right? 2 PM 2
8:30 pagi, doktor.
8:30 bukan kelas Cik Zam
Bukan.
Kan?
2-3 doktor.
2-3 kan? Okay. So esok lah 2-3. So hari ni kamu try dapatkan table tu dulu. So esok kita nak guna table tu untuk calculate kita punya tu soalan tu. Kalau siapa dah biasa buat tu cari balik lah. Okay lah? Alright, so thank you. That's all for today. See you again.
Terima kasih doktor.
Alright.
Thank you, sir.
Thank you, sir.
Terima kasih, doktor.
Thank you, sir.